All right, squirrel. You ready? Okay. So, what did we do before? Yeah, that's right. You weren't here. This is what happens when you're absent. I know. You should feel shame. It's okay. I love you anyway. She says she was taking a break. It's important to take breaks, isn't it, Squirrely? Yeah, it's important. Okay. Let's take a look at what we're going to be doing with this break packet. Break packet, we've got inequalities. I did number 1 with you guys. Number 2, this is in y equals mx plus b form. So we're starting at -5. Yeah, -5 is all the way down there squarely. And then we go up 2 over 2, because that's our slope. Now, squirrel, do you remember if it's a dotted or a solid line? It's been a very, very long time since we've done that. Yeah, this whole big inequality, that means that it's got to be dotted. If there were a line underneath, then it would be a solid line. Looks like this, and we are shading y is bigger than, so we are going to be shading bigger than. You could have also just graphed this on your graphing calculator had you wanted to do that. So we've got our beautiful graphing calculator right here. I would delete the equal sign, go down to relationship, enter, and then we would say y is greater than, so control equals greater than, right there, 2x minus 5, enter, and hey, look at that. Isn't that beautiful? Notice, what did they do wrong? When it first shows up, it shows up as a solid line, but if you click off of it, it's going to be a dotted line right there. Okay, next one, you have to graph those two and figure out which picture it is. So let's take a look at that one. And if you graphed it in your calculator, this is what you should get. I've got funny pictures, or funny colors, but it is what it is. You're going to get that guy right there. Number 4, very similar to number 2, only you have to solve for y if you want to do it the way that I did it, or plug it into your calculator. And for this last one, I am seeing that they're shading above, so I can automatically get rid of this guy and this guy. The slope, we are going up, so it's going to be a positive slope, so be it is. And then we've got 6. Okay, and if we type those two into the graph, we get this very ugly looking thing. If you notice, the lines are parallel. So we've got a nice axis, we've got steep parallel lines, and they're both shaded below. So one is shaded like this, and the other one shaded like this. And they overlap on that side. Okay. I want to get the lined grid on here so that we can take a look at this sucker. Let's take a look at 1 1/2. 1 1/2 is over in this white section over here. So A is not going to be helpful. That's not going to be in our solution. 0 6 is all the way up here, also in our white section. So that would be a no. -1/2 and then up 5. 1, 2, 3, 4, 5. That's actually on one of the dotted lines. On one of the dotted lines, not allowed. So we've got -3, 1, 2, 3, and then up 2, and that is right there. And that's going to be our answer because that's in both of them. So that's how we're going to do number 6. All right, I'm jumping a lot today. Let's take a look at number 7. An online electronics store must sell $2,500 worth of printers and computers per day. Each printer costs this much. Each computer costs this much. The store can ship a maximum of 15 items. Okay, so we need to do inequalities. So let's get a set of inequalities on here. Normally we do a let statement and do printers and computers, but we don't have to do that. So the printer is $50. So $50 for each printer plus $500 for each computer. And they want to sell at least $2,500. So the printers and the computers, we would want to be bigger than or equal to 2,500. Okay, next one is the orange. Maximum of 15 items per day. So if you have all the printers and all the computers ready to be shipped out for the day, maximum there can only be 15. So it's got to be less than or equal to 15. All right. So now we need to actually graph this sucker. I'm going to go back to our calculator. And with the calculator, we are going to type this in, but be very careful when you type this in. When we type this in, we can't use P and C. We have to use X and Y. That's the first thing that we need to worry about. The second thing we need to worry about is these numbers are ridiculously big. That's 2,500 is not what we are used to seeing. So we might need to adjust the scale. We got X plus Y is less than or equal to 15. Graph that guy, and we get this. Okay. Hey, look, I can just drag it, and that works. That's exciting. Okay. Now, if we cared about the regions, which we don't, we would have to do this pretty, but we don't. So we're going to do this. The first one is in red, and it looks sort of like this with pink on top. And then the other one is gray, so we'll call that orange. And it cuts like this, and we'll make this guy orange. Orange, and it goes like this. And we have to determine a combination of printers and computers that would allow the electronic store to meet all of the constraints. Any of these right in here would work. All of them would work. So I'm going to start with what was my X. My X was printers, so one printer. So printer being 1. And computers being how many computers? If I only sell one printer, 1, 2, 3, 4, 5, let's do 6 computers. That would work. 7 computers would also work. 8 computers would work. All of these would work right here. Say I wanted instead to sell 5 printers. 1, 2, 3, 4, 5. That's this line. So any of these would work. So 1, 2, 3, 4, 5. 5 printers, 5 computers. Or 6 computers, or 7 computers. I don't know. Figure out what you want. You can put any of them there. You've got a lot of options. Not infinite. Well, sort of infinite. But not really. Because printers have to be whole. You don't want to sell half a printer. That would be awkward. Although I've seen some students try and write that for this question. I'm going to sell 5.5 printers. That sounds like a terrible idea, child. Don't do that. All right. Real Good Cinema is conducting a mathematical study in its theater. There are 200 seats. So 200 seats. Adult tickets cost this much. Child tickets cost this much. They need at least this much. Write the system of linear inequalities to find the possible combinations of the adult tickets and child tickets. graph the solution, mark the solution set, and then determine if selling 30 adult tickets and 80 child tickets will actually meet the goal. Remember, the goal in this case, their goal is money dollars. They do not care about filling seats, they only care about money dollars. So let's do the money dollars equation since that's what's most important to them. So $12.50 adults plus $6.25 for each child. We want to be bigger than or equal to $1,500. And if we added all of the adults plus all of the children, there better be less than 200 of them. That's the important part. Better be less than 200. Okay, so that is our system of inequalities. You would then go to your calculator, graph them, try and graph them on this graph, mark where they cross, where they're both shaded, the S. So this is S because this is where they're both shaded. And then determine if that is true. I will let you finish 8 by yourself. Let's go to number 9. Sum of two numbers, x and y, is more than 8. Okay. X, sum means plus. Plus y is more than 8. When you double x, so two x's, and add it to y, plus y, the sum is less than 14. Less than 14. Okay. These are the two inequalities. Graph the inequalities. Kai thinks this is a solution. Determine if it is actually a solution. I'm going to let you do number 9. At least see what you can do. Sean incorrectly graphed the inequality below. Aw, poor Sean. Fail. Okay, let's take a look at what Sean should have done. Sean should have just plugged it into his calculator. But you know, no one trusts Sean. Sean's got some issues. Sean might be squirrel. It's okay, she can't hear me. She went to the window. She's trying to fend off her own territory. I feel like there might be a cat across the street. Okay, so this is what he should have plugged into his calculator, enter, and he should have gotten that. And what did he do? He's got the solid line, that's all good. He went 1, 2, 3, 4, that's all good. Steep slope, really all he did wrong was shading. That would be the issue right there. Shading. Shaded wrong. Poor Sean. Slash squirrel. Okay, so let's correct poor Sean's mistake. We gotta go down 4, 2, 4, and then the slope is down 1/2. We've got a nice solid line. Solid line. Solid line, like this. And shade. That's what number 10 should look like. Super exciting. And that is how we do inequalities. If you have issues with inequalities or would like to chat with me about inequalities, please message me. I want to talk about details of graphs next. For your details of graphs section, I'm going to do the first one with you guys, and then I'm going to set you free to try and figure out which ones you can do. And I'm also extending the deadline of this packet. I misread my map. I'll blame it on Squirrel. It's not Squirrel's fault, but I can blame it on her. Okay, toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by this equation. Beautiful equation. Let's graph it. When in doubt, get me a picture. Always. in math, when in doubt, get a picture. Plus 64x. Notice I'm using x's, and this got to be a y in front. Okay, that does not look pretty. And it does go up to 64-ish, so let's go up to 20. Oh, no. I was right, it's got to go higher. 50? Nope. 100. Yay! Look at that, our beautiful parabola. Okay, determine the domain for this function. Domain. Now, this one's actually a trick question, one of my absolute favorites. So what happens is we've got this rocket. This rocket is launched at 0, 0. It goes up into the air, and then it comes down, and then it lands on the ground right here at about 4, 0. And it goes all the way up to like 60 something. That's what, 2, menu, analyze graph, maximum, check maximum, 264. Okay. We want the domain. Notice our rocket stops when it hits the ground. It does not burrow into the ground towards the Earth's core. It's a toy rocket. If it were a real rocket, probably burrowing to the ground, through the ground to the Earth's core. But no, it's a toy rocket. As soon as it hits the grass, it stops. We are looking for the domain, which is our x values. Domain is left to right. So let's take a look at this. Left to right. That's this way to this way. How far did it go? Well, we know it has to start at 0. It looks like if we take a look at this graph, it has an extension here, but we don't include that. We don't include that because this is a toy rocket, and t is talking about the time, and height is talking about above the ground. We are not going to have -1 seconds. He is this far below the ground. Not for a toy rocket. So we're starting this sucker at 0. And he is going all the way until he hits the ground again, which is over here at 4. Now, normally we would put x in there because that is what a domain is, but notice when we typed it into our equation on the calculator, instead of putting, it doesn't have x's in the equation, it has t's. So, this one is a super special trick question, one of my favorites. I actually like this guy. For the others, I gave you basic ones. What is the domain? What is the range? What is the range? And they're all very straightforward. This one even gives you a picture of it so you don't have to graph it on your calculator. So for those of you who are having issues with your calculator, don't have to worry about that one. This one's talking about y-intercepts. This one's talking about zeros. Zeros. What do zeros mean? Zeros is another word for x-intercepts, where it crosses the x-axis. All right. So your mission is to try and start these details of graphs, take a look at zeros, take a look at minimums, at maximums, have fun with that guy, which is not labeled, should be labeled. That's your y-intercept and an x-intercept. Range, domain, good stuff. You're going to be looking and trying to do through Yeah, through page 34. So you're going to be finishing through page 34. The packet isn't due next week. I think the packet I want due on April 27th. Does that sound right? Yeah, let's do April 27th. And I will do a full video just on how to turn in this packet so that you get credit for it. Because a lot of my COVID grading is going to be based on, did you attempt? Did you watch my videos? Did you try? All right. I need to go intervene before Squirrel scratches through the window. I will talk to you later. Have a wonderful day.